linear algebra student. This video is for chapter 4.5, part 2. Continue with discussion of dimension of subspace. Just want to give one more example. So this is another way of describing a subspace. So they do it horizontally. If you do it that way, that means it's just a horizontal vectors. It's still R3, but they do it horizontally. So what happened is this vector is such that a minus 3b plus c is 0, but 2a plus c equals 0. So instead of saying what a, b, c's are, they just set the relationship between them. Now, so just be aware that this is different from what we have talked about. It's still about a, b, c, but this, for example 3 in part 1, we talk about how each one is described by a, b, c, versus these are not. A, B, C is not a linear combination, it's not all A or real number. They are only specific set of A, B, C, but they have satisfied this equation. So you can say that this set is actually contain solutions of, so you will say X is the solutions of an equation of A minus 3B plus C equal to 0 and 2A plus C equal to 0. So this actually means you want to find a homogeneous solution of ABC, and where A is actually the matrix is 1, -3, 1, 2, no B, 0, and then 1, right? And we wanted to solve 0. So what are those that would satisfy these? So that's paid back practically now of A, right? Node of A would be, yeah, so we need to solve now A. So need to do RREF of A to find now A, because I want to find a basis. The only way you do is that. What was it? 1, -3. Did I enter it? Yeah. 1, 2, -3, 0. I think here. 1, 2, -3, 0, 1, 1, 0, 0. So this is the augmented matrix of solving AX equal to 0. So if I do a REF, it will be 1, 0, 1 half, 0, 0, 1, -1, 6, 0. Okay, write down 1, 0, 1 half, 0, 0, 1, -1, 6, 0, right? So we see there is a free variables. This free variable is x3 that would produce your null A, because you can write it as x1 equal to -1 half x3, x2 equal to 1/6 x3. So all of x3 is x3, right? So ABC, which is the A1, the solution for this would equal to x3 multiply -1 half, 1/6, and then 1. So the basis would be this. There's only one, so it must be linearly independent, right? So any x3, where x3 is free. The important is that the one is free. That means you can generate anything that would satisfy this equal to 0, and it would be in H. And this is the basis, so dimension of H is equal to 1. Okay. So that's the finish solving the dimension of any subspace described in various different ways. Just don't mix up this particular description. They're not describing all ABC like in this one. Okay, a lot of people confuse about them because they use ABC. The next thing is to talk about the geometric meaning of subspace in R3. So if it's a zero-dimensional subspace, it only have the zero vector. The only thing that is in it is the zero vector, so it's a point or something. A zero vector, I should say. If it's a one-dimensional subspace, so everything is of a combination or multiple of that particular vector, so it's a space spanned by one vector, so these are lines through the origin. And a two-dimensional vector, just like the solution that we talked about before, if you have a linear combination of two vectors, it span a plane through the origin. Three-dimensional would always span the whole R3. because IMT said that any 3 linear independent vector will span out 3. So the last things we want to talk about in this section is how do I find dimension of null A and column A if someone give me a matrix. So this matrix, you can consider it having n vectors that are, arranged in columns, and the dimension of each vectors is m. So first is to find dimension of null A, and we talk about how to generate null A, just like here. But actually briefly talks about here. Null A is a set of vectors satisfy Ax equal to 0. It must be the number of elements in the basis must be equal to the number of free variable. So if you have k free variable, there will be k linear independent vectors. They must be linear independent. So if you have multiple of these, they are linear independent. So they would be forming a basis for null A. So k is the number of free variable in the REF or RREF of A. If you want to find the basis, you need RREF. If you just want to know how many, REF is good enough. Okay. What about column A? Column A means just the linear combination of all the vectors in vertical columns of A. So that would just means that it's equal to the prefix columns of A in REF form. So you don't need to do RREF. You just need an REF form. You need to know which prefix columns are prefix columns, and then the original columns are basis of column A. So for example, do an example. So I have this big matrix A, and I want to find dimension of column A. So notice that it is already in echelon form, right? Not reduced, but in echelon form. Did I spell wrong? So what is the prefix position? This one, this, nothing, right? Nothing. So I have 3 prefix column. So that is equal to 3. So this is the dimension of column A, because the corresponding, so we don't know. If this is A, then these 3 columns would be the basis. But if this is a REF, you need to go back to the original one to find the prefix column. And then the dimension of null A would be the free variable, right? So one free variable, free. This is free. And the last one is also free. So I have 3 free variables, so it's also free. Some true and false. So there are a lot of independent bases, dimensions, so how they related to each other. So see if this is true. The dimension of P4 is 4, of course, no, right? So P4, the standard bases are 1, T all the way to T to the power 4. So we have 4 entries, right? And this is a basis, so the dimension is equal to 5. It's not 4. Okay, so B, if dimension of V is n, we know its dimension S is a linear independent set, then S is a basis for V. Is it? Well, it may be, but we don't know how many elements it have, right? If it is a linear dependent set, only if S has n elements. If you only have 2 elements, they are linear independent, it cannot be a basis, right? So false. Because only if S has an element. If N has less than n element, although it's linear independent, it may not be a basis. Okay, so that's all for 4.5.